In 1988, 7 astronomers completed a survey of the entire sky. Their target list held roughly 400 elliptical galaxies, and for each one, they measured not just distance, but motion. It was patient work, spread over years and hemispheres. For that patience, history would nickname them the 7 Samurai. The dots on their maps refused to sit still. Beyond the steady expansion of the universe, galaxy after galaxy carried an extra drift, and the drifts all pointed the same way. 400 islands of stars were streaming together, like driftwood drawn into one slow current. Many of them lay hundreds of millions of light years out, and still the pattern held. But the region they streamed toward was a blank on the map. It sat behind the plane of our own Milky Way, where dust and crowded starlight swallow the view. On every optical chart, this blind spot carries a dry label, the Zone of Avoidance. It hides about a quarter of the sky. The star atlases of that era resembled a great book with one long cloudy band smeared across its most interesting page. Whatever our galaxy could not see through, the survey could not see either. The pull was real, measured, undeniable. Its source was invisible. The team gave their unseen culprit a name, the Great Attractor, but a name was all they had. Then came the detail that turned curiosity into mystery. This was not the first hint that something was tugging on us. The sky itself had been whispering it for years, in a signal written into the oldest light there is. 11 years earlier, the whisper had already been heard. In 1977, a detector rose beneath a high-altitude balloon, flown by George Smoot and his colleagues. Their target was the cosmic microwave background, the faint, leftover glow of the early universe. That glow should be almost perfectly even, 2.725 degrees above absolute zero, everywhere. Except it wasn't. One side of the sky came back slightly warmer, the other slightly cooler. The difference measured 3.36 thousandths of a degree, about 0.12%, just over 1 part in 1,000. A familiar effect explained the lopsidedness, the Doppler shift. Motion squeezes the light ahead of a traveler and stretches the light behind. So the warmth was not a feature of the cosmos, it was a speedometer. A discrepancy that small sounds like noise. For cosmologists, it was a headline. The numbers it returned were startling. Our sun moves at roughly 370 kilometers per second. The whole local group, the Milky Way, Andromeda, and their smaller companions, moves at 627. 627 kilometers per second is New York to Los Angeles in about 6 seconds. In 1992, the COBE satellite confirmed the pattern with full sky maps, painting the warm pole and the cool pole in unmistakable color. There was no longer any doubt. Everything around us is falling towards something. But the fall points at nothing we can see. It does not aim at any bright cluster or known giant. Rather, the vector runs into the dusty band of our own galaxy, the same blind zone that swallowed the 7 Samurai survey. 2 experiments, 2 blind spots, 1 direction. The hunt could begin. By the late 1980s, the race was on. The team's 1,988 paper had put a number on the invisible hand. To explain the measured drift, something out there had to weigh 50 quadrillion suns. That is 50,000 Milky Ways, gathered into one gravitational fist, a few 100 million light years away. Nothing anyone had cataloged came close. Then came the problem. Whatever was doing the pulling sat squarely behind the Zone of Avoidance, the dusty band of our own galaxy that blocks a quarter of the optical sky, 1 star field in every 4. Against that fog, the finest optical telescopes on Earth were decoration. On every optical map, the most important spot in the story stayed blank. Refusing to accept that was Alan Dressler, one of the 7. He championed the hunt for years, popularized the name that stuck the Great Attractor, and later wrote a book about the chase. The label was honest, an attractor, nothing more. Whatever it was, no one could say. Here's a realization that reframed the mystery. The blindfold was not distance, it was home. The Milky Way's own dust, the same haze that makes our galaxy so beautiful on a dark night, was hiding the very object dragging the Milky Way across the sky. Every telescope we aimed at the mystery met our own stars first. We were being pulled by something our galaxy refused to show us. The hunter was the hiding place. One question now ruled the field. What kind of thing can hide behind an entire galaxy and still pull on one? The trick was to stop looking with light we could see. Radio telescopes read the 21-centimeter line of neutral hydrogen, a signal that sails through dust untouched. Where starlight failed, X-ray surveys picked out hot cluster gas, and infrared instruments cut straight through the haze. Seen this way, the zone of avoidance stopped being a wall and became a window. Then, in 1996, came the payoff. Renée Kron-Korteweg and her colleagues announced the Norma cluster, a swarm of galaxies comparable to the Great Coma cluster. It sat almost exactly where the pole had been predicted to peak, hidden behind the plane of the Milky Way. It had been there all along. 8 years of prediction finally had a target. Numbers followed. The core lies about 225 million light years out, and the broader attraction carries something like 10 quadrillion suns, the weight of 10,000 Milky Ways, pulling as one. Leaner than the first estimate, still colossal. That distance lands hardest in deep time. The light arriving from the Great Attractor tonight left its source when Pangaea stood assembled and the Great dying, the worst extinction in Earth's history, had only just ended. No dinosaur had yet walked. That is how far nearby reaches in cosmology. There is a certain embarrassment in the discovery. Decades of sky surveys, and the missing giant turned out to be a mountain range in the backyard, hidden by the house itself. Still, the celebration came with a shadow. The Great Attractor should have settled the case. The mass found, the distance fixed, the name earned. It didn't. Something in the numbers refused to add up. 2 decades of detective work ended with an audit, and the audit failed. In 2006, Dale Kachevsky and Harold Ebeling tallied the pull of every X-ray cluster they could weigh. The Great Attractor, the whole hidden mass behind the Milky Way, accounted for about 44% of our motion, less than half. The rest of the ledger pointed somewhere else entirely. But the trail didn't go cold. It got longer. 650 million light years out, light that left home before Earth's oceans, hosted complex animals, sits the Shapley Concentration. Harlow Shapley logged it in 1930 as an odd clustering of galaxies, decades before anyone knew we were falling toward it. It is the richest pile of galaxy clusters in the nearby universe, and much of our fall toward the Great Attractor is really a fall through it, onward to Shapley. Then came the stranger half of the story. In 2017, astronomers mapped the emptiness behind us and found it was not innocent. A vast cosmic void sits opposite our direction of travel, and its relative nothingness shoves us forward, pushed as well as pulled. They named it the dipole repeller. And here is where this stops being astronomy. You are moving at 627 kilometers per second right now, fast enough to circle the Earth in about a minute. You've been falling that fast since the day you were born. So has everyone you have ever met. None of it was ever optional. So the case reopens. If the Great Attractor isn't the destination, what is? In 2014, Brent Tully and the Cosmic Flows team flipped the detective work on its head. Stop asking where the mass is, they argued. Map where the motion goes. Using distances to thousands of galaxies, they traced the currents of galaxy flow, following each stream the way hydrologists follow rain. Then they drew the watershed, the surface where neighboring flows divide, a continental divide written across the sky. One of those watersheds holds us. Their map outlined a single basin of roughly 100,000 galaxies, spanning some 520 million light years. Light that began its crossing when the first shelled animals were new. The Milky Way sits near its outer edge, a suburb rather than a center. They named the basin Laniakea, Hawaiian, for immeasurable heaven. The name earned itself. Nothing larger had ever been given one. So the dots we once watched drift were never drifting at all. They were rivers. And rivers have basins? If the Milky Way were a single lighted window in a sprawling nighttime city, Laniakea would be the entire metropolitan area. 100,000 windows, all of them draining toward one bright downtown. Still, one honest caveat belongs here. A 2024 reanalysis hints that our watershed may itself sit inside a still larger basin centered on Shapley. The maps are provisional, maps always are, but a boundary on a flow map is a direction, not a wall. It marks where the current runs, and that current runs somewhere we have not named yet. A watershed is not a cage. Every chase has a ledger, and this one's is unforgiving. The Great Attractor's core lies 70 million parsecs, out 225 million light years, more than 2,000 galaxies, laid end to end. An expansion carries it off at 4,900 kilometers every second. Earth to moon in 80 seconds. Our fall toward it manages only 600 times a rifle bullet. Do the subtraction. We close at roughly an eighth of the rate it retreats, and the retreat is speeding up. But the deeper twist is quieter. Measure the Norma cluster against the cosmic microwave background, the one true rest frame, and its peculiar velocity comes back consistent with 0, minus 72, plus or minus 170. The Great Attractor is not running from us. It is standing still. Expansion simply takes it. Then, the fate turns out to be shared. Laniakea, our own supercluster, fails the same reckoning. Not dense enough, not bound, destined to disperse. It is a pattern in the flow, not a fortress. Only the tightest cores will ever collapse into something permanent. So the chase resolves into a verdict. We will fall forever. We will never arrive. The arithmetic permits no appeal. Dark energy signs the guarantee. Consider a rower on a river, pulling at 8 kilometers an hour against a current running 64. The rowing never stops. Neither does the current. The shore slips away at 56 kilometers an hour, patiently, forever. The wake is real, the arrival is not. That is the Milky Way's itinerary, written in moving water. One question remains, and it is an honest one: whether our motion is even normal. The bulk flow of galaxies in our region looks larger than the standard model of cosmology comfortably predicts. One 2023 analysis puts the tension near 4 sigma, a fluke of roughly 1 chance in 30,000. Another, on the same catalog with different statistics, finds consistency once estimator errors are modeled. A third reports 3 sigma at some depths. But this is an unresolved fight. Both sides are serious, and both are reading the same sky. Referees are already on the field. Wallaby's radio Tully-Fisher distances, Desi's peculiar velocities. Their verdicts should sharpen within the decade. So take stock. Behind the dust, a hidden mass. Behind that, a larger one. Off to one side, a void that pushes. Around everything, a supercluster that will dissolve. 4 layers of one story, each stranger than the last. None of it was visible. All of it was measured. Still, the cosmos owes no closure, and tonight it offers none. Now return to the map. The cloudy band that smeared the old star atlases is smaller. Radio eyes have pried it open, line by hydrogen line. Yet the last blank on the map may not be a place we have not seen. It may be a place we will never go. The Milky Way falls on 600 kilometers every second Earth to moon, in 11 minutes toward a horizon that falls away faster. What better definition of a calling than to chase what can never be reached?